I should first apologise for being one of 4 very different accents in this session, and also for the lack of subtitles on my slides, because people constantly tell me they can't understand what I say, so hopefully you'll understand some of it. We actually work on roundworm parasites, as Sue mentioned, and GI nematodes. And we have 3 different Alma funded projects at the moment, one on cattle, one on sheep, and one on bison, because these parasites are important in different ways to all those host species. And I'm really going to talk about the cattle and the sheep to start off with today. The bison I will not have time to cover, but some of the same principles apply. If you can imagine a cow on that picture, to introduce the organisms that we're talking about, these are roundworms that live in the GI tract. Animals become infected from the infective stages which are on the pasture. And that list of species you get on the right is just some of the species which infect cattle. And so when you look in the GI tract of cattle, they really are a complex community. And the kind of tests that we use typically are just simply looking at the presence of eggs in feces, and many of you will be aware of that. And that really does not reflect either in terms of sensitivity or in terms of species diversity, anything like what's happening inside the host. I've got pictures, which is good. So one of the big take-home messages from this talk is the fact that we've been very fortunate the last 30 years, I guess, to have several very potent and very effective drugs, which are also very cheap. And this has allowed us to control parasites in a way that we almost forget about them. And there's this quote I've put down here from Thomas Fuller, who basically said, we never know the worth of water until the well is dry. And in the case of anthelmintics, the well is becoming dry, and has continued to do so over a number of years. So on this slide here, I'm not going to go into the details, it's just to give you an impression of the status of anthelmintic drug resistance in parasites in both sheep and cattle. So if you look on the right, the figures for sheep basically show that in many countries of the world, I'll talk about Canada in a little while, but in many countries of the world, resistance is more normal than susceptibility in these parasites. So places like Australia, Europe, actually on most sheep farms, most of the parasites are resistant to most of the drugs. In cattle, this is a somewhat different situation, and it's only in the last 5 or 6 years we've become aware of the growing problem of resistance in cattle parasites. But actually, as people have now started to look, and again, if you look at the figures from Australia and cattle there, we see the situation isn't that far behind sheep in many respects. And so a recent study from Australia showed about 50% of farms have 1 or 2, or resistant parasites to 1 or 2 of the only 3 classes of drugs that we have available. So the situation globally is quite serious. Whoops. And what my lab does is it works on this problem in a variety of ways. And we do both basic research, which is really aimed at trying to understand the mechanisms of resistance. And we do applied research, which I'm going to talk about more today. But I wanted to make a comment about the interplay between these two, because I think having the two side by side is absolutely critical if we're going to develop innovative approaches and find solutions to problems. And this is where Alma, certainly in our lab, comes in, is funding that link between the basic and the applied. And without Alma funding, to be honest, we really wouldn't be able to make that linkage. As I said, roundworms affect all our livestock species, but the way they manifest themselves is quite different in the different host species. So in sheep, we have a lot more clinical disease, it's a lot more obvious. We have fatalities, and I'll talk about that in a little while, so it's very obvious to producers. In cattle, at the other end of the spectrum, we don't see clinical disease in this part of the world very often, and so therefore it's more of an invisible problem, which is more of a production problem, and people are often not aware of the production losses they're incurring in terms of in this situation where control is gradually being eroded. And so what do we mean about production loss? And so if we look at North America as a whole, we're talking about billions of dollars per annum And this is this subclinical production loss, which occurs by a variety of mechanisms, but one of the most important is the appetite suppression you get with GI parasitism. So this image of this aerial shot of these pastures is really brings this home, because if you look at that central pasture, that's a pasture grazed by cattle where parasite control has been good with anthelmintics, and the adjacent pastures are pastures where it's been poor with the same stocking density. You can see a quite dramatic impact on the grazing of those pastures, and you can imagine how that translates to weight gains. And there was an interesting study in 2007, which was a meta-analysis of over 170 studies, which basically showed or made the point that the loss of dewormers to the beef industry across North America, its economic impact is something around threefold that of the loss of growth protein hormones. So you can see how important these tools are, and the fact we've been taking them for granted for a long time. The other issue, which has been talked about already, so I won't harp on it, and everybody's very aware of it, is going to be increasingly important for producers to actually show the need to use pharmaceuticals and to actually use them in a responsible and targeted way, and that pressure is building all the time. So the bottom line of all this is that the approaches we've relied on for the last 20 or 30 years are not really sustainable, partly due to resistance and partly due to the changing consumer attitudes and regulatory environment. And so this brings a whole slew of research needs that we now have to produce better diagnostic tests, to understand the parasite epidemiology better so we can apply these in a much more targeted, effective and sustainable way. And that's really on the applied side of what we do in the lab. That's the heart of it, really. So going back to the beef situation, when you look at how important these things are to the industry, it's kind of amazing how little we understand about them. We don't really know what the infection burdens are in most situations. We don't know what the impact is in an individual situation. We don't know even what species are present in Canada. We don't know how effective the control regimes we're using are, and we don't know what the situation of drug resistance is. So there's a huge number of simple facts that we have no clue about. And so that prompted us to initiate this project, which was funded by Alma, and we actually also collaborated with Roy Lewis through Merck in terms of getting access to samples to really look at a number of these questions, but actually in very broad terms. So this chart here basically shows the fecal egg counts of about 45 herds of calves coming off, beef calves coming off pasture. And you can see across the country, the typical egg count you're getting in about 50% of the herds are over 10 eggs per gram. Now, there's no real magical formula you can say what that means for production, but suffice it to say it's very similar to what you see in the northern US states and the northerly Midwest, where we know these production impacts occur. But in terms of specific information for specific situations, we don't have the tools to assess that. The other question we wanted to address is how effective are the control so that people are using, and obviously beef producers rely on ivermectin effectively. That's the almost exclusively has been the single approach. And so we looked at the efficacy of those treatments. And basically what you do is you take egg counts before and after treatment and look at the percentage reduction in the egg counts. And so this histogram shows the results of that. And red is effectively bad, which is a category of those forms falling into a category where the efficacy of the treatments are less than 50% in terms of reducing egg counts, and white is good where the drug is working very well. And you can see if you look at the Alberta figures, about a third of herds fall into the category of suboptimal efficacy. And that's very similar to what has been shown in the US. And so in those terms, the situation is quite similar. Another part of this project we wanted to do is to improve the diagnostic tools we have. And actually, if you look at parasitology, the tools have barely changed in the last 20 or 30 years. And when you look down the microscope at these eggs, which are the egg counts I'm talking about, all that range of different species and biodiversity all look the same. And so so what we wanted to do is really develop an improvement of our ability to tease out what's going on in terms of these different species, which, as I'll show, I think is quite important. And the approach we adopted was very equivalent to microbiome type sequencing that we heard about 5 minutes, okay? The microbiome type sequencing that we heard about from Trevor, actually, but we've applied it to worms. And so basically what you do is you can culture feces, extract several thousand larvae from each fecal sample, prepare DNA, and then sequence a DNA target, which will tell us what the species are, and then sequence at great depth. And so what we can do is generate 10,000s or several tens of thousands of DNA sequences from each sample in parallel, and that will give us species proportions in those samples. And that allows us then to see what these parasite species are that we're looking at with the egg count. So to give you a flavour of the results, these are, again, those 50 herds across the country. You can see, and this just represents with colours the different species, with each bar basically representing a different herd. And you can see there are 3 predominant species that we find. The blue is Ostatasia ostatagai, which is somewhat bad news in one sense, in the sense it's the most pathogenic species. And actually, in the US, this has become less common in recent years, but it seems to be that in Canada, it's still the predominant species. Another thing we did with this is to look at the impact of those ivermectin treatments. And so what does that do to the species composition? And so if you look at this, as I transition the slide and look at the blue, you can see there's quite a dramatic shift of those parasites which survive the drug treatment. And really, there's a lot of issues around this, but the take-home message from this is when you treat an animal with an antiparasitic, you're not simply reducing the parasite burdens, but you're changing that parasite community. And that can be a good thing, or it could be a bad thing if you're shifting it to more pathogenic and harmful species. And an example of that is the orange on there, which is really a species which is traditionally thought to be mainly in the Midwest and southern US, a Cuperia punctata it's called, which is highly pathogenic. And it's an example of that, certainly in eastern Canada, some of these ivermectin treatments appear to be selecting for that. So I think there's a lot more we need to do to look at the impact of treatments and what that means for sustainability. So I'll just finish off with a couple of slides on a sheep study, and just to try and give you a flavour of the different elements to this. And we've started an analogous study, if you like, with sheep, but the situation in sheep is quite different, as I described, and you see much more clinical disease. And so part of the reason for that is this parasite called Homunculus contortus, which actually is a blood feeder. So it causes huge amounts of gastrointestinal hemorrhage, it causes anemia in sheep, and that's what's shown on the top 2 slides there. And mortalities are quite common. And when I came here 6 or 7 years ago and spoke to sheep producers, the awareness of this parasite was only just becoming apparent. And certainly if you go back 10 years, it was unheard of, effectively. But now, over the last 2 or 3 years, it's increasingly common, and it's one of the producers' main concerns. And so it's an example of a disease which has just emerged quite rapidly in just a few years. And I think resistance is part of the reason for that. So we did a pilot study, and this was a clinical colleague, Michelle Levy, who's been mentioned before, actually, by Stephanie, who we hired a summer student from the DVM program to do a pilot study. And Lorna Swain is her name, and she did a fantastic job of this project, actually. And what she did is she collected samples used from around 20 farms across Alberta. And if you look at the blue list down on that chart, you will see the egg counts there. And I won't say shocked, but very surprised at just how high they are. We've got egg counts in the thousands of eggs per gram. And then when you look at the chart on the right, which is where we've applied these deep sequencing approaches to look at the species, the red shows the proportion of this blood-feeding species Homunculus. So we can see about a third to a half of the farms have predominantly Homunculus, and those are at risk of clinical disease. So this really confirms those anecdotal reports that this is an emerging parasite. So what we did is we went onto the farms, and just 4 farms in this pilot study, and looked at the efficacy of the 2 available drugs. And really, if you look at the percentage figures, that's the percentage egg count reductions. And the bottom line is, with the 2 only available drugs in Canada at the moment, all 4 farms had resistance to both drugs. So obviously, this may be part of the reason for the emergence of the parasite, because the drugs are no longer doing the job they're supposed to do. So in terms of the Alma projects we've got at the moment, we're expanding these surveys, and we're applying these technologies to really get a much clearer understanding of the prevalence of the different parasites and the epidemiology. But also we're designing a number of new technologies to actually directly measure the resistance in the parasites, so that people can send samples in and we can say, this drug will work on this parasite population, this drug won't, etc. And this is all really aiming at having a much more targeted, focused and sustainable approach to parasite control. The whole issue of how we integrate these technologies is into the real world, if you like, is a whole subject in itself, and that's part of these projects. Just acknowledgements, I've already mentioned Michelle, Lorna and Roy. Libby Redmond's a postdoc in the lab, who's done a huge amount of work on this, and Russell Avramenko is a graduate student. Those are the 2 people who've really done most on this. I'd also like to thank all the producers who have collaborated on this, so thank you.